Hey guys, how are you doing today? Today we're going to look at proving more triangles congruent, and we're going to learn two new theorems, angle side angle and angle angle side, so that we can do that. So let's go ahead and get started. Today you're going to learn about the angle side angle postulate, the angle angle side, and again how to prove them triangles congruent. Just as a quick review, look at this real quickly and pause it. What additional info do you need to prove the triangles are congruent by the given method? So go ahead and pause and see if you can get it, and then play. So for side angle side, in order for us to prove that this is congruent by side angle side, I've got to prove that angle J is congruent to angle T, because remember we want that included angle, the one that comes right between them. For the last example, for side, we want FH congruent to SU. And that would prove those triangles are congruent. Moving on. So we have this new theorem, angle side angle, and I changed the diagram a little bit. Maybe you can turn yours upside down. And basically it says that if two angles in the included side of one triangle are congruent to two angles in the included side of the other triangle, then the two angles are congruent. So right now, we're given in this drawing that we have angle A congruent to angle D. So we have this here. We're given that we have side AC congruent to side CD. And then we have our vertical angles. For ease, I'm just going to name them angle 1 and angle 2. And those are vertical, and we know that all vertical angles are congruent. So we have got an angle, a side, and an angle, a side, and an angle. So those are congruent, and it would be triangle EDC congruent to triangle BAC. So we want to keep them, order is important. Okay, moving on to the next postulate that we have. It's called the angle angle side, or AAS. So if two angles in their non-included side of one triangle are congruent to two angles in a corresponding non-congruent side of another triangle, then they're congruent. So I've got angle F congruent to angle D, and I have angle G congruent to angle E. Now this time we don't want the side included, so we don't want this side that's between them. We want in non-included one. In this diagram, I've got DF congruent to itself, and that would be my non-included side. So DF would be congruent to DF, or better yet, if we just flipped it around to FD. Okay, so we've got that congruent to itself by reflexive property. And if my niece is watching, it's her favorite property. It's the only one she knows. She swears. She knows a lot more than that. But triangle FED then would be congruent to triangle DGF. Okay, because of the way those angles are switched around, the F's don't necessarily line up. So you got to be careful with that. Okay. So those are our two new postulates. So let's look here and decide whether or not we have enough information to prove that these triangles are congruent. Okay, so I've got an angle, I've got another angle, I have a side, and sometimes using highlighters works. I've got a side, and look at this, I have another side here. So yes, I can prove them congruent by side angle side. Now that wasn't one of the ones we learned today, but we learned it yesterday, okay, or in the last lesson. Here, it doesn't look like we have much, but because ML is parallel to NO, we know that we have, and if you make that Z, we know that we have this angle congruent to this angle because they're alternate interior. Okay, and that's all we have, and then we have this side. Okay, so I've got an angle, a side, and a side, and it doesn't work that way. So remember what I said about this? Bad word, bad postulate. So we don't have enough information to prove that that is congruent. So now we want to state the third congruence needed to prove that triangle CAM is congruent to triangle PSU. So if I know that, and these are three separate problems, if I'm given that CA equals PS, and I'm always marking the diagrams, angle M is congruent to angle U, and what else do I need to know by angle, angle, side? Okay, well, by angle, angle, side, I either need to know that angle A is congruent to angle S, or, so it'd be this one and this one, or I need angle C is congruent to angle P. So either of those work. Okay, so let's look at the next one. I'm going to get rid of the color, what I've written down, so we don't confuse it. We start in a whole new problem. Okay, so now again, I've got caps. I guess I could have left caps. So CA congruent to PS, and I've got M congruent to U again. This time I want side, angle, side. I've got a side, I've got an angle, but it's not included. So what I actually need are the two sides that are going to, I need a side and an included angle. So I could say A and S. So angle A is congruent to angle S. And then I could say, because I've got this side here, this angle, I have to have this side congruent. So then I also have to have side MA is congruent to side US. So it'd be congruent to here. So now I have a side, the angle, and the side. Next example. Get rid of all of this again. And we'll start with what we know. So we know that, again, CA is congruent to PS, M is congruent to U, and actually I just repeated the problem, so we don't need to go over that. Bad typo for me. All right, so you got two examples. All right. Again, more. Can we prove these congruent? Okay. Well, I've got a side, an angle, and a side. I've got a side, and an angle. So these I cannot prove are congruent. For this, I've got vertical angles are congruent. So I've got an angle, a side, and an angle. An angle, a side, and an angle. So we can by angle, side, angle. For this last example, I can say that this side is congruent to itself. So I've got an angle, a side, and a side. And again, that's a bad postulate, so no, I can't prove that those are congruent. All right. So now I've got a proof, because you know we got to do proofs. So what I do, and they've done it already, is they've marked it up for me that I've got angle LOM, which is this angle right here, congruent to angle NPM. And I have LN congruent to this. So what I have is I've got an angle and I've got a side. So of my postulates, I have side, 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 angle, side, angle, and angle, angle, side. So the only thing that it looks like I can do is I can say that I've got these vertical angles congruent. And that's what we're going to use to prove. So I can do that by angle, angle, side. So now to write it down, my first statement would be my givens. Angle LOM is congruent to angle NPM. And side LM is congruent to side NM. And those are my givens. My second step is just going to be to say that angle LOM, angle LMO is congruent to angle NP, NMP, and that's because vertical angles are congruent. Use the angle symbols. And now I've got enough to prove the triangles were congruent. So I can do that. I can say that triangle LOM is congruent to triangle NPM, and that's from angle, side. So there is my congruency there. All right, let's look at one last proof. All right, so we're given that B and D are right angles and AE bisects BD. And remember, with proofs, we want to go from kind of where it was stated. So I'm going to start with this given. I'm only going to use the one. Okay, so I've got AE bisecting BD, and that's given. From that statement, I should know, since AE bisects BD, I should know that BC and CD are congruent. And they are by definition of bisector. Okay, and that's all I can do right there with that statement. So next I'm going to say that angle BCA is congruent to ECD, or DCE, because my vertical angles are congruent. So we're almost done. We just have to deal with the right angle now. So the right angle B and D are right angles, and that's given. So you guys see how I split up the givens? I split them up because that makes it easier and more logical to follow. And because they're right angles, we know that they're congruent because all right angles are congruent. And now we have enough to prove our triangles are congruent by angle, side, and an angle. So they are congruent by angle, side, angle. Okay, so now that we've done lots of proofs for this year, we're going to start stepping it up the game so that you've got to do them all on your own. So you've got to be reviewing your theorems and postulates. So today I have talked about angle, side, angle, and angle, angle, side, and how to use them to prove that two angles are congruent. I hope you guys have a great day, and I'll see you in school.